Hello students, I hope you are well. Last lesson we talked about the 3 phases of a warm-up. Today we're going to talk about the 3 phases of a cool down. If you want to access the lower grades, then you just have to give me the basic facts. Tell me what the 3 phases are and give me a brief definition. That is written in red ink. If you want to access the middle grades, then you have to apply it. Tell me what you will be doing and how you will be doing it. So apply it. And to access the higher marks, that's written in green, that's the critical evaluation. Why you are doing an active cool down. What are the strengths of an active cool down? There aren't actually any weaknesses to discuss. It's just the strengths in the critical evaluation for today. Now, there is going to be quite a lot of extension at the top end because I think it's important you have a more rounded knowledge of the concepts around cool down. But I will let you know when we're going to talk about more complicated concepts which are actually above GCSE level. They might be A-level level. Okay, so straight off onto the first phase of the cool down. The first phase is an heart rate reducing activity. Heart rate reducing activity, that's just simply jogging for 10 minutes. At least 10 minutes at the end of your activity. Why do we jog at the end of your activity? Well, it's to maintain an elevated rate of respiration and circulation. You want to keep your breathing depth and breathing rate high. You want to keep your heart rate and your stroke volume high. Because if you have those higher levels of If you maintain those higher levels of minute ventilation and cardiac output, then we can breathe in the oxygen, that's the golden substance, and then we can transport it to our muscles because that oxygen is crucial during a cool down. Why is oxygen so crucial during a cool down? Well, this is that higher end A-level stuff. 65% of the lactic acid you build up in your muscles will never leave your muscles. If we get oxygen to it, it's turned to pyruvic acid and then that's metabolized in the mitochondria via the Krebs cycle into energy, carbon dioxide and water. The remaining 35% of the lactic acid is flushed out to the liver where it's converted to glycogen, glucose and protein. So it's really important in that first phase that we maintain elevated rates of respiration and circulation so that we can actually remove the lactic acid. We can flush out the lactic acid. I'm going to introduce you to a phrase called DOMS, delayed onset of muscle soreness. If you don't get rid of the lactic acid, then the next day that lactic acid causes your muscles to be sore. They ache. So it's important that we flush out or get rid of that lactic acid so that we reduce the likelihood of getting DOMS. Okay? Lovely. Second phase is stretching. Now, what stretches do we do? Well, remember in the warm-up we do active stretching, passive stretching, we do dynamic stretching and proprioceptive neuromuscular facilitation, PNF stretching. Well, in the cool down, the most important type of stretching is static stretching. That's where you, if I want to stretch out my hamstrings, I would touch my toes and I would hold that stretch for at least 10 seconds. That's static stretching. We do it in the warm-up as well, but particularly important in the cool down. Why do we do stretching? Well, it's got 3 reasons. The first reason is that it elongates the muscle fibre so that oxygen-rich blood can flow through it. Remember that oxygen is going to turn the lactic acid into energy, carbon dioxide and water, 65% of it. And the remainder, because oxygen-rich blood is flowing through the muscle fibre, it will take it to the liver. Why else do we do stretching? Well, in your training session, hopefully you will have got micro tears in your muscle fibres. Those micro tears actually facilitate eventually muscle hypertrophy. And there is evidence that stretching speeds up that process, helps those micro tears to repair quicker, more effectively. And the third reason why we do stretching is because, and you might not put this in your GCSE exam, I would go for the top two. The third reason, when you've just exercised, your muscles are at their warmest. So take advantage of it. If you stretch during that cool down, your muscles are at their warmest, so you'll be able to stretch them further than they've ever stretched before. It's a form of overload. You will improve your flexibility. So phase 1, a heart rate reducing activity. Phase 2, stretching, 10 minutes on each, at least. And then the third phase is refueling, where you need to rehydrate and you need to replenish your nutrient levels. So during exercise, you will have lost a lot of water content because water via evaporation is used to thermoregulate. You sweat in order to maintain a stable body temperature of 37.4 degrees. You will have lost a lot of water and you will have lost a lot of salts. So it's really important during the activity to drink water, but after it, during your recovery, during the cool down, to drink water. Put electrolytes in that water, put the salts in the water and replenish those salt levels. The nutrients that you will have depleted are the carbohydrates, or the glycogen and the glucose. You will have used those fuels for energy creation in your muscles. The longer your activity and the higher the intensity, the more that they will be depleted. So the more carbohydrates you have to consume afterwards in order to get them back to your resting levels. I've also talked about here, it can take 24 to 48 hours to replenish your nutrient stores fully. If you've done a marathon, it's going to take you 48 hours to get those glycogen levels back to resting levels. I've also put in here ice baths during this third phase. So you jump into a bath of freezing cold water for 3 minutes. What that does is that it vasoconstricts the blood vessels. It really vasoconstricts them so that your internal body temperature stays warm. So it vasoconstricts, which you think is counterproductive. It is. But after that 3 minutes, if you jump out of the pool, then your blood vessels vasodilate to the biggest they can, allowing that oxygen-rich blood to flow through the muscles, and it helps to remove that lactic acid. It helps the muscles to recover quicker. So ice baths are a really good idea, and most elite sportsmen use them. Sports massage will also speed up recovery time. So they're the 3 phases of our cool down. We have phase 1, a heart reducing activity, jogging, gentle jogging. And then we stretch, particularly static stretching. We consume lots of water, we rehydrate, we refuel our glucose, our glycogen levels. All right, this little phrase here is crucial that you try and remember for your exams. An active recovery will maintain an elevated rate of respiration and circulation, which prevents blood pooling so that oxygen can metabolize it to energy, carbon dioxide and water. The remainder is flushed out to the liver. An active recovery will speed up recovery time and reduce the likelihood of DOMS. Now, I did say that we would do quite a lot of extension at the top, so I'm going to draw your attention to this diagram. We did look at this diagram when we talked about warm-up, when we talked about doing an active warm-up in order to reduce oxygen deficit. Today I'd like to draw your attention to oxygen debt. We repay an oxygen debt at the end of exercise. In GCSE science it will be referred to as EPOC, excess post-exercise oxygen consumption. It's the amount of extra oxygen we need after exercise to get back to homeostasis or to resting levels. It's the amount of extra oxygen you need to get rid of lactic acid, if you like, in simple terms. Now there are 2 parts of EPOC, or oxygen debt. There's a fast recovery part called the alactacid recovery, and there is a slow part called lactacid recovery. This fast part you recover within 3 minutes, and that's about recovering ATP, PC and resaturating myoglobin with oxygen. It takes 3 minutes. The first 3 minutes of your recovery will be about ATP, PC and myoglobin stores. After 3 minutes, it's the slow part of recovery, and that is about getting rid of the lactic acid. So you can see why a cool down needs to take 20 minutes. A really effective cool down needs to take 20 minutes. Remember that you don't just recover at the end of the game, you recover during the game as well. The whistle may go, there's a break in play. Stay active, keep walking, do some stretches. You will recover that lactic acid, so when the whistle goes again, you're ready for your next burst. Okay? Lovely. My GCSE class, what I'd like you to do now, please, is this attachment will be on Show My Homework. So take the attachment off, pop it onto your mobile phones and add it to your lesson library on your mobile phones. I would like you to copy it into your blue book, please. And then I would like you to revise it for 30 minutes. Give some questions to your parents and get your parents to test you. Okay? Please stay safe, stay well. Thank you.